cloud. It's the cloud. All right, so we got biodiversity today and conservation. And so we've been really dancing around the idea of biodiversity all semester. I basically gave you the definition the first day in class. And so we sort of have a general idea of biodiversity, but we're going to get a more nuanced definition today, more in-depth definition today. And the question we're going to try to answer, I don't have any quotes for today. I couldn't find a good quote about biodiversity that I liked. But the question we're going to try to answer today, outside of the fact that these polar bears are absolutely adorable. I mean, look at this guy. Look at this one. They're so little chunky guys. Why should we protect a polar bear? Why is one species important? Why do we care about this one species, right? When we think about climate change and the effects of climate change, polar bears are always brought up as a species that's heading towards extinction. So why do we care about a single species? And if that species isn't human, why do we care? So we're going to try to answer that question today. Keep this in the back of your mind as we're going through things. We'll loop back and talk about it at the end of class. Get your opinions, see what you guys think. So let's get a more rigorous definition of biodiversity. So as we spoke about, biodiversity breaks down as life and diversity. You guys know, right? Diversity, how many different things we have, right? So if you think about humans, if we have a very diverse group of humans, we have someone from England, someone from China, someone from Japan, India, and so on and so forth, right? That's what we mean by diversity. But when we apply it to a species, or I should say towards nature, we think about it in three distinct contexts. So the first one we've already discussed is how many different types of species do we have? If I have 100 species, we would say that's high biodiversity. It's also sometimes called richness, species richness. You'll see that as you sort of peruse through readings and stuff like that. Lots of species is called high species richness as well. So that's the one we sort of already defined. Now, it is a bit more nuanced to that. Now, within a single species, and I think the human sort of population shows this really nicely, there's a vast reservoir of genetic diversity as well. So every human on the planet, regardless of how different we look from one another, is all part of the same genus species, Homo sapiens, right? That's our genus species. So given that, we can look at how different we all look. Usually this is easier when I have you guys look around the classroom, but even if I had you guys look at each other's videos, there's lots of black screens, so it's not as effective of a tool when we're on Zoom. But you guys know when you head out into Boston, when you head out to any large city, it's a pretty remarkable diversity of traits, right? Skin colors, heights, weights, eye color, skin tones, whatever you could think of. That's the genetic diversity we're talking about. A large diversity of traits. And again, that's not just a human thing. That's also a thing for elk and cows and sheep and any animal you can think of, including bacteria, including viruses. Everything you can think of, there's monstrous amounts of genetic diversity out there. I just put this in one last sort of perspective that will get you thinking a little bit more about what genetic diversity means. When they say different strains of COVID, that's the genetic diversity we're thinking about, right? We have the Delta variant of COVID and the Alpha variant of COVID, right? That's just genetic diversity within COVID as a virus. So, and it's also sort of an underlooked aspect of diversity as well. Just as a note, when people think about biodiversity, this is sort of the last thing they think about. And then finally, we went really small. We went to the molecular level here. Then we went to the level you can see, and then we'll finish off by talking about what our final level of biodiversity, and it's the ecosystem level. As we discussed, the Earth has different ecosystems depending on where you are. And remember, an ecosystem is an interplay between the living and the non-living, right? Rocks and squirrels, right? The river and trout, right? That's what an ecosystem is. But within a given sort of region, if we have a bunch of different types of ecosystems, this is simply what we would call ecosystem diversity. And it is in itself a metric of biodiversity. Now you might ask yourself, why is ecosystem diversity a metric of biodiversity? Well, the reality is if you have lots of different habitats, as we sort of see here, we have grasslands and forests and shields and foothills, those all have different conditions, right? Different environmental conditions, or what we would call abiotic conditions. And because of that, it invites more species diversity and more biodiversity as a whole. So really, ecosystem diversity fosters more genetic diversity as well as biodiversity. So it is an important aspect of diversity as a sort of way to think about the environment. So, clearly, all of these things have the capacity to be affected by humans, right? We can eliminate ecosystem diversity by harvesting this boreal forest, right? We could build a park here, right? We can change this level. We can change biodiversity by, say, overfishing, right? We can also change genetic diversity by overfishing as well, right? So we have the capacity as humans to change biodiversity at all levels. Now, as we've mentioned, ecosystem services, they're super duper valuable, right? Trillions of dollars on a yearly basis provided to the economy free of charge, here and abroad, obviously. But really, and we sort of didn't quite get, I didn't really put this idea out there at the time, but I sort of alluded to it. But the idea that what really underpins ecosystem services is biodiversity. So when we talked about provisioning services, you can't have healthy provisioning services without biodiversity. You can't have regulating services. You can't have cultural services, and you can't have the sort of the backbone services that ecosystems provide without biodiversity. So biodiversity gives us ecosystem services, thus giving us economic value of the ecosystems that we think about. So whenever we lose species, we potentially lose ecosystem services. So if we think back to our example of the Florida Everglades, where we talked about the Florida Everglades, we changed the water flow, we lost two vibrant fisheries, the bonefish and the tarpon fisheries. We lost biodiversity in those fish, and we also lost the provisioning services that those fish provided for us, in addition to the relatively large economic value of that fishery to the state of Florida. So again, these ecosystem services, super important, not just for you, but agriculture, business, whatever, but it is solely underpinned by biodiversity. And again, biodiversity at all three levels. Changing this all to one type of ecosystem reduces this, thus reduces the ecosystem services that this area could potentially provide. So kind of a cool link, right? I think this class links really well to that ecosystem services class, really thinking about what gives ecosystems value, because again, it is really the organisms living there that do it. If there was no life, there would frankly be no ecosystem value, right? So we can ask the question next, and I think it's a good question to ask: where is biodiversity found? And the reality of it is actually just everywhere. I hope when you guys survey your backyards in your backyard biodiversity lab, I hope you realize how species rich where you are is, right? So I live in Massachusetts, south of Boston. Even I know when I go to my backyard, there's dozens and dozens of species living out there that I can see, and many, many, many more that I can't see. So biodiversity is all around us, from the top of the atmosphere all the way down to the bottom of the oceans. Biodiversity is everywhere, which is kind of a cool thing. Can't escape biodiversity, which is a good thing. However, there is what we call biodiversity hotspots. Now, biodiversity hotspots, I'll show you a map of some hotspots in a moment, but they're basically areas where biodiversity is relatively relatively increased relative to, say, normal biodiversity in a comparable area. And so you can ask yourself, why are biodiversity hotspots more diverse than other areas? And they actually have a high amount of what we call endemism. And endemism is actually, is when a species is only found in that one area. So we actually talked about an endemic species already. We talked about the Florida manatee when we talked about the Florida Everglades. And I told you guys to Google manatee flippers, because you can see their little fingernails still. I always find that cool. But you see the manatee here. It's only, this species of manatee is only found in Florida, in the Everglades. Thus, it is endemic to the Florida Everglades. So given that, you could imagine the Florida Everglades is a biodiversity hotspot, and you would be absolutely correct. So biodiversity hotspots are found everywhere. And so this is just a handy dandy map where we have terrestrial hotspots here, and in like pinkish, orange, salmon, whatever color you want to call it. And then we have marine biodiversity hotspots in blue. You'll notice that there's quite a few biodiversity hotspots on the land, not so much in the ocean, not very much at all. But does anybody see any patterns to this data? I mean, it's not really data, but does anybody see any patterns in this map that you think is interesting? Well, if I were to have you look in the Pacific Ocean, what's going on over here? We got one person in the chat. Okay, so coasts seem to be a hotspot. That's good. The near the equator, that's also a good thing. Nicholas, what do you have to say?
I mean, the terrestrial biodiversity and then the marine is like they're pretty close to each other. They seem to be related.
Yeah, so we got a couple good things. Lots along the coasts. You're absolutely right about that. Lots of it near the equator, so tropical areas. I'm sorry, so I saw someone raise their hand, but it went away on me. Abdullah?
Yeah, Professor. I raised my hand.
Yep.
I was just also gonna try and point out that I think that like all of the, I think that like a really important point is to talk about the climate here, like because I feel like all of like the orange spots are in relatively, you know, hot climates.
Yep, no, that's definitely true. They're all near the equator, so they're all warm. And as we discussed, the equator gets constant sunlight throughout the year. Thus, it has a pretty consistent climate year round. And it's sort of this cool thing. The more consistent the climate, the more biodiversity there is. It's kind of a cool thing. So actually, interestingly enough, as you go north and south away from the equator, biodiversity gets less and less and less. It's kind of a cool thing. So we got stable climate, we got the equator, warm temperatures, lots of things on the coast. Anything else? Anything else you guys see? Well, the one thing that I'm surprised, no, someone always gets this one, is oh, one person got it, I hope. Mostly islands. Yeah, that's a great point, Megan. Yeah, that's the sort of the one last thing I wanted to make mention of. Lots and lots of islands. And it's really highlighted by Madagascar, our own Caribbean islands here, all throughout the Pacific, as well as, you know, the Indo-Asian islands here. Lots of biodiversity on islands. So it's a pretty cool thing. So lots of biodiversity on islands, lots of biodiversity in the equator, lots of biodiversity in stable, warm climates. Pretty cool. So good job. The other thing I just wanted to make mention of is, and just to sort of think back to our last class, or no, last class, so anyway, one of our previous classes, we were talking about population biology. Lots of biodiversity hotspots near the coast. And remember, humans like to settle near the coast. And so we're living oftentimes in biodiversity hotspots, right? So think about how many people live in this part of California, right? How many people live in this part of Florida? How many hundreds of millions of people live in Brazil, right? So thinking about this sort of humans like biodiversity hotspots. So it's kind of a wild thing. Lots of biodiversity hotspots, lots of biodiversity on islands. Does anybody have any idea why islands might sort of invite biodiversity? It's a kind of a hard question. So I don't, even if you have a thought, it's always good. Yeah, so they're secluded. They definitely have land, water, lots of animals. But yeah, one of the big things is they're actually secluded. When something gets secluded, it invites all sorts of unique innovations to respond to living on an island, because it's much harder to live on an island than it is to live on the mainland. So good. All right, so that's biodiversity. That's where it's found globally, but there are hotspots, and we love as a population to live near those hotspots. So you can clearly see there's some overlap between biodiversity and where humans like to live. So let's define some definitions, and we could do this actually with a really successful piece of legislation. And this is the United States Endangered Species Act. It was enacted in 1973. And so we'll define an endangered species as something that is in danger of becoming extinct throughout all or a significant proportion of its range. And that's one aspect of the endangered species list. You could be any different types of endangered. And then the sort of the more the better part of being on the endangered species list is the threatened species part, which basically is defined as a species is likely to become endangered within the foreseeable future. So I have two examples here. We have the vaquita. I love this picture of the vaquita. They're really critically endangered. There's just like 50 of them left in the world. But I love this picture of this vaquita, even though it's dead, because it looks like it's just like smirking. Just look at that face. He's just smirking. Critically endangered marine mammal. And then we have an example of the West Indian manatee, found obviously in the Indo-Pacific Islands. It is threatened as a species. So the Endangered Species Act, adopted in the United States, it's not like a global thing. It's not through the United Nations or anything like that, but a lot of countries have followed suit with the United States. And the United States did base their laws on some other countries' laws as well. But most countries across the planet have some level of protection for endangered species similar to the Endangered Species Act. So now, to date, the Endangered Species Act, or the ESA, protects about 1,600, 1,650 in that ballpark, endangered or threatened plant and animal species. Now, just highlight, that sounds like a lot, right? But just to sort of put this in perspective, there's about 1.2 million species on the planet. So 1,600 of them are on the Endangered Species Act. That's not a huge proportion, right? So it's pretty good. But the Endangered Species Act is actually really, really successful. It's actually one of the few environmental policies that has a ridiculously high success rate. Because as we talked about, ecosystems are dynamic, so protecting things is oftentimes hard. But this act was really good. Now, about 99% of the species placed on this endangered species list have actually not gone extinct, which is pretty remarkable. If you think about it, right? Just by putting them on this list, it affords them a numerous amounts of protections, which keeps them from going extinct. And as we'll sort of discuss, once something is extinct, like say the passenger pigeon, it is gone forever. So Endangered Species Act, really, really important. Now, in 2019, so during the last presidential administration here, there was some pretty severe weakening of the Endangered Species Act, not set forth by Congress or anything like that, but set forth by the president. And I like this quote from the New York Times because it describes really well what the previous administration has done. It says, for the first time, regulators would be allowed to conduct economic assessments, for instance, estimating lost revenue from a prohibition of logging in a critical habitat when deciding whether a species warrants protection. And I hope you guys can see that's just a silly thing to do, right? For many reasons, but if the purpose of an act is to protect species, you should protect the species because they need to be protected, not because a logging company might lose a few $1 million, right? So that sort of change in the policy is pretty at odds at the purpose of the Endangered Species Act. The other thing that happened, and this is actually still going on, is that species that are characterized as threatened actually no longer receive the same protections as species that are considered endangered. That was one of the cool things about the Endangered Species Act. If you were threatened, you were afforded all the protections that something endangered was receiving. So it was a really important thing to sort of maintaining threatened species and keeping threatened species from becoming endangered. And the other thing, that was some pretty severe changes in language about how we talk about the foreseeable future, i.e. what timeframes do we have to talk about something becoming endangered or becoming extinct? It really essentially extended it out. Really, really brought it in. It had to be like, it's going to go extinct within a couple of years, as opposed to it will go extinct within a decade. So lots of hampering to the Endangered Species Act, which again has been very, very successful. But I will say this first point was actually rolled back by the Biden administration, which is good. But these other two remain in some way, shape, or form, but they are not as, thankfully, they're not as detrimental as they used to be. So the Endangered Species Act, very, very successful, but has, depending on the administration, some pretty severe limitations can be placed on it. Now, the Endangered Species Act, as we mentioned, has been very, very successful at keeping things going extinct. And extinction just means when something is no longer found on the planet at all. And so I gave you the example of the sea cow. I'm sorry, the sea cow. I'm sorry, looking at my picture of the stellar sea cow, but that is another species that has gone extinct here. We have the stellar sea cow here, but I gave you the example of the passenger pigeon when we talked about the tragedy of the commons. That's a species that is extinct, right? It's no longer found on planet Earth. But there's many, many examples of this. if you guys have ever watched like Ice Age, every animal in Ice Age has gone extinct, right? The saber-toothed tiger, the woolly mammoth, right? But you can also think of things that happened, relatively recently, like the dodo bird and the white rhino is just about to go extinct. So lots of species can potentially be lost. And this quote is really sort of hits home that when something goes extinct, it's forever. That biodiversity is lost forever. But if there's something is endangered, you could still have time to potentially save that organism. Now, there's another term that you'll see quite often is extirpation, where a species that is, say, normally found in Canada and all throughout Central and South America is pushed out of one area of its natural range. So, for instance, the pygmy short-horned lizard here, looking, I don't know, a little bit evil here with his mouth open, trying to thermoregulate. It was extirpated from Canada due to a variety of reasons, but is no longer found in Canada, only found in Central and United States, Central America and the United States. So that's an example of extirpation. Now, a more local example of extirpation is actually the rattlesnake. The eastern rattlesnake used to be found in Massachusetts in the Boston area, but because people didn't want rattlesnakes in a heavily populated area, we actually locally extirpated rattlesnakes from the eastern part of Massachusetts. So you really don't find rattlesnakes in eastern Massachusetts anymore, really only found in western Massachusetts. Though I will say, people that, like, if you've ever been to the Blue Hills in Milton and Quincy and Randolph, some people swear you can still find rattlesnakes there, but for all intents and purposes, the rattlesnakes have been extirpated from eastern Massachusetts. So pretty I don't know, I guess a pretty cool local story. But again, extinction, gone forever, extirpation, I just kicked you out of your home, or at least part of your home, I should say. Okay, so what is the current state of biodiversity? So there was a very, very large report in 2019 called the Global Assessment Report on Biodiversity and Ecosystem Services, which is put forth by the United Nations Intergovernmental Panel on Biodiversity. So it's just another one of those NGOs that we talked about. There were some pretty key findings, and I think this quote from Robert Watson really hits the point home. It says the decline in biodiversity is eroding the foundations of our economies, livelihoods, food security, health, and quality of life worldwide. And I think that really says all I would technically need to say, but I'm going to talk about some important aspects of this report in just a second. But it should really put forth the idea that global biodiversity as a whole is declining. And it's declining not because it's a natural thing, it's declining because of human or anthropogenic activities. So we are currently in the middle of our sort of one of our great biodiversity loss events currently. So let's talk about some of the things that we found from this report, because they are pretty important. Now, depending on who you ask, there's about 1.4 to 1.8 million species that have been scientifically identified on planet Earth. Now, what does that mean? It means a scientist found them and gave them a genus species name. Like our genus species name is Homo sapiens, right? So for something to get that genus species name, a scientist has to discover it, characterize it, and then give it a species name. So that's what it means when we say we have 1.4 to 1.8 million species. However, the reality of that number is it's actually likely an underestimate. We actually think there's probably closer to about 4 to 6 million species on this planet. We just simply haven't discovered them yet. And you might ask yourself, how haven't we discovered species? Well, jungles of the Amazon, of the sub-Saharan Africa, the deep parts of the ocean, there's untold life in those parts that we just have not found yet because it's hard. Right? It's hard to find new species. So we have a lot of species, but there's a lot of species that we simply have not found yet. So you might sort of think like, oh, that's pretty cool. And I would absolutely agree with you that that's really cool. There's species that are not known to science. But the reality is, if we don't know about those species, we can't protect them, right? We can't give them endangered species protections, right? If they're undiscovered, that means they could disappear before we ever find them. So kind of an amazing thing, but also a little bit scary at the same time from a biodiversity perspective, of course. Now, globally, if there's this many species, about 1.4 to 1.8 that have been identified, we think there's about 1 million planted animal species that are headed towards extinction. They're headed towards being on that endangered species list. And so remember, we said that endangered species list right now has about 1,600. Could you imagine how big that list is going to be as we progress, as we lose more and more biodiversity going forward? That's not very, that's a list of like, I feel like it's, if you have a million things threatened with extinction, it's easier to make a list of things that are not threatened with extinction, right? As nihilistic as that is. So that's the big takeaway. Global biodiversity is declining in plants, in animals, in fish, in arthropods, insects, whatever you can think of, it is declining at the global level. So that's the main takeaway. And again, this quote from Robert Watson really hammers home that point. Now, the other thing we're seeing is about 82% of wild mammalian biomass is gone. Now, what does that mean? Well, it just simply means there's 82% less animals out there, less squirrels, less, like African animals like lions and tigers and all that stuff. 82% of that is simply gone. And interestingly, when we actually look at if we sort of look at all mammalian biomass on the planet, 96% of all mammalian biomass is actually just found in humans and our farm animals. So only 4% of all mammalian biomass is wild animal biomass. Globally, 40% of amphibians, most of it occurring in the tropics, but still a lot of it occurring here in the United States, is threatened with extinction. If you might ask yourself, why are amphibians threatened with extinction? There's a really nasty fungus that humans are spreading called chytrid that is killing our amphibian populations worldwide. That could be a whole class on itself, so I won't dive any more into it, but the fungus is called chytrid, CHYTRID, if you're interested in frogs and salamanders and things like that. Globally, we know half of corals have disappeared since the 19th century. And as I sort of alluded to in the water section, corals support huge amounts of fish biomass, which provides a huge food source for about 2/7 of the world's population. So about 1/3 of the population on the planet. We've lost about we have about a third of our marine mammals are threatened with extinction. I showed you the vaquita, I showed you the manatee. There's many, many more species out there that are threatened with extinction. And actually, this number is wrong. There's actually a recent report that actually showed this number is closer to 40%. I forgot to update the slide. About 40% of insects globally are threatened with extinction. And again, you might not think that's a big deal. You might not like insects, and that's okay. But do know insects are really, really important to the functioning of ecosystems, and they make up most of the sort of living material in ecosystems. So if insects go bye-bye, the ecosystems go along with it. So I know it's an exciting prospect to think, oh, there'll be no more mosquitoes, but that would be a very bad thing. So, all right. So let's that's our status of biodiversity. It's grim. It really is. So just to sort of tell you where we're at, we are currently, given all this, in the middle of the 6th great mass extinction on this planet. You might ask yourself, what defines a mass extinction? Well, a mass extinction is simply defined as the potential or the capacity to lose 25% of all species. You might ask yourself, when's the last mass extinction? And you guys already know the answer to this question, because everyone loves dinosaurs. And if you say you don't love dinosaurs, I don't believe you. Everyone loves dinosaurs, and the last great mass extinction was 65 million years ago, and it wiped out our dinosaurs friends and about 50% of life on the planet. So we are in a very, very, very dire state. That's where we're at. Biodiversity is globally not in a good position. And again, biodiversity underpins ecosystem functions. So without biodiversity or a loss of biodiversity, we start to erode away our ecosystem functions, the services that they provide, and in turn, start to erode our economies, our livelihoods. And so as I sort of mentioned in the population biology class, one of the things we think is going to most heavily limit human population growth going forward is how much environmental degradation there is, right? And that really gets back to the changing biodiversity problem. So with that grim stuff out of the way, let's talk about more grim stuff. A lot of the stuff we talk about in this class is doom and gloom, unfortunately, and that's just sort of the state of environmental science at most times. But let's talk about the IUCN list. It's a pretty important list. So it's the International Union for Conservation of Nature. It's basically a guide to revise international agreements, including the the Convention on Trade in Endangered Species, or CITES Act. It's also sort of part of the UN's Convention on Biological Diversity. And so it's a global group of people that provides, or I should say, an institute that provides data on species health, allowing them to sort of, very much like the Endangered Species Act, but at a global level, put things on this list. And it ranges from extinct in the wild. So you could think of like things that are only alive in zoos, but are extinct in the wild, things that are critically endangered, and then that vulnerable. And so vulnerable is sort of, we've already mentioned what that is, like it's heading towards being endangered. Then we have sort of things that are least threatened and least concern, like they're getting to the point of being vulnerable. Things that are of least concern are things that are like, we don't really think there's any change, like squirrels, for instance, are of least concern. It's actually kind of interesting. The IUCN list is pretty pervasive, but if you've ever like wanted to know about a species and you went to Wikipedia, it will give its IUCN status, just as a note. So if you are interested about any IUCN status, you can visit their website, or you can also check Wikipedia, because Wikipedia does incorporate this. So that's the IUCN list. We'll come back to this in just a moment, but I want to just sort of come back to the idea of the economy and biodiversity. As we've mentioned, biodiversity underpins ecosystem services, and the reality of it is, we're thinking, when we start to think about sort of what this biodiversity loss means in global economics, economists estimate that biodiversity loss in Europe, just in Europe, nowhere else on the planet, is estimated to cost about 3% of the EU's GDP per year. And so that's not a huge fraction, right? I mean, 3% is not very much, but again, it's still lost GDP, GDP that potentially never will come back just because of the way we treat nature. Now, in addition, global biodiversity loss, we estimate by about 2050 will total the total global economy about $15 trillion per year. So we're talking about no joke sums of change here, right? 3% of GDP is small, but global by 2050, talking about trillions of dollars per year. And that is no joke in terms of a loss to the economy. That's basically like losing the entire Chinese economy, right, from the face of the planet, right? And China is the second biggest economy on the planet. So again, this is no joke. Now, what is the economics for protecting species globally? Well, protecting all the world's threatened species, we estimate, would cost between $4 and $76 billion. It depends on who you ask. Or it depends how the math is done. So clearly not a huge chunk of change, right? $4 billion is, for at least on the global stage, is basically nothing. And even $76 billion is still only 10% of, say, our military budget on a yearly basis. So it's not a lot of money to protect a huge sum of money, right? And that's one thing I hope you guys really take away from this class, is protecting the environment is not super expensive. And it has some huge rewards at the back end, and they're not mutually exclusive. So let's talk about how we can sort of value this. And we'll talk about two distinct types of ecosystems here. We have a mangrove. Mangroves are really cool. They're forests. They're basically on stilts. They exist in the Caribbean as well as in Asia, but they're pretty well known in. If you guys have ever been to Puerto Rico or the Dominican Republic, those are well known ecosystems in those areas of the world. So really cool ecosystems. Now, they're coastal ecosystems, so they do provide a lot of coastal protection. So they provide protection against storm surge as well as erosion. And that totals at about $3,000 per hectare per year. So note $3,000 per hectare. And remember, a hectare is about 2.5 acres. So just by existing, right? That's what we're talking about here. They're not like, they're ecosystems, right? They're not like doing anything, right? They're just existing. So $3,800 a year just to protect our coasts. They're fish reserves that they provide, because mangroves are great fish nurseries, provide about $70 per hectare per year to local fisheries. And they're forest products, i.e. when you cut a mangrove tree down, you can sell it for, again, about $90 per hectare per year. So they provide both regulating services as well as provisioning services at a value of about $4,000 per hectare. Now that's in relative to a shrimp farm, so something that is directly a provisioning service. And you'll see that the profits from shrimps is about $200 per hectare. And that's not a lot of money for a hectare, right? Especially relative to the $4,000 here for a mangrove. Now, the reality is there's also direct and indirect costs here. So there's direct costs to the shrimp farmers, where they have to take care of their pollution, and as well as direct costs to the state or the country where a fish farm is, and you have to clean up pollution. And that's a net drain of about $230 per hectare per year. A shrimp farm also, as every aspect of our agriculture is, whether it's aquaculture, growing cows, or growing corn, everything is subsidized by federal governments worldwide. And so that subsidies come out to about $1,700 per hectare per year for a shrimp farm. So I hope this sort of this stark dichotomy of a good, healthy ecosystem versus an ecosystem that's strictly for provisioning services are really in pretty strong diametric opposition here, where shrimp farms, they're not worth very much. And the same could be said about soybean farms or corn farms. They're not simply worth as much as a natural ecosystem. Now, I'm not saying we shouldn't have farms, because obviously we have to have farms. But when we're thinking about biodiversity, protecting biodiversity and keeping ecosystems intact is extremely valuable, right? And I think this $15.5 trillion per year by 2050 really hammer homes that point. Again, really valuable. Biodiversity is so valuable. So as I've mentioned, the current rapid decline in biodiversity that we're currently experiencing was originally called the biodiversity crisis, but it's actually just simply called the sixth great mass extinction event, as I've already alluded to. So now the reality is, you might, and a lot of people will argue, extinction is natural, and that is absolutely correct. Extinction is natural. It is. It's just part of nature. But the reality is, when we actually look at how fast extinction is occurring during the Anthropocene, it's 100 or up to 1,000 times higher than those prior to the Anthropocene and pre-industrial times. So is extinction natural? Yes, absolutely. Absolutely. But the rate at which extinction is happening can only be explained by one thing, and that is us and what we are doing to the planet. So let's talk about, how did we get into this mess? How are we in the middle of a mass extinction event? And unsurprisingly, it's just sort of things we do. And so I'm going to give you a quote from E.O. Wilson. So he's the guy we talked about in the very first class, really famous biologist. And E.O. Wilson said, the decline of Earth's biodiversity is an unintended consequence of multiple factors that have been enhanced by human activity. They could be summarized by the acronym HIPPO, with the order of the letters corresponding to their rank in destructiveness. So we have H is habitat loss, I invasive species, P for pollution, P for population, and O for overharvesting and overuse. So we're going to talk about these two today. We're going to talk about pollution. We've talked a little bit about pollution thus far, but we're going to talk more about pollution later in the semester. And we've already talked about population and overharvesting and tragedy of the commons. So we've already talked about P and O here. We've already talked about PO, and we're going to talk about high today and P later in a later class. But you can really sort of see this in one of the poorer regions of the Western Hemisphere, and that's the sort of the dichotomy between Haiti and the Dominican Republic. You guys probably know they're both on the same island in the Gulf of Mexico. Both of which, these countries are very, very poor, unfortunately, with Haiti being the poorest country in the entire Western Hemisphere, and it's been that way for quite a bit of time, unfortunately. But you can see Haiti and the Dominican Republic. You can see the line. You can see the border between the two countries. And you see one country that has pretty dang good environmental policies and one country that has very, very poor environmental policies. And you can see HIPPO working its magic here in Haiti. Let's talk about some HIPPO things. And the first thing we're going to talk about is actually habitat loss and habitat fragmentation. Now humans, we fragment habitats, and now you might ask yourself, what does a fragmentation look like? Well, it looks like one of three things. So we can look at a forest example here where we've logged this forest, leading to small patches of forest here, here, and here, creating a fragmented habitat. We can also fragment habitats by putting roads. So you can see this road going through this nice forest, cuts this forest in half, cuts this ecosystem in half, fragmenting it. And then we can see an example here where we have a seagrass bed. A boat went through here with its propeller multiple times, chopped up the seagrass bed, made a bare spot here, thus fragmenting this seagrass bed. So it happens both on the land and in the ocean, as well as in lakes and stuff like that. So humans are great at breaking habitats into small patches. And you might think to yourself, why is this a big deal? Well, I'm going to give you a story because I think stories from sort of common experiences that we probably all have experienced are a good way to illustrate how these things work. So as I mentioned earlier in the semester, I moved my sister from Rochester, New York, all the way down here to Massachusetts. So I had to drive a moving truck 6 hours from Rochester down here. It's really, really boring because it's all just highway. It's I-90 all the way. It's really boring. However, when I was driving this truck through these forested areas, I have this fragmented habitat situation. Now, as I was driving, I saw a car like swerve. And I was like, what is going on with this person? And I couldn't see anything on the road. And then I got closer and closer and closer. And I had frankly, a oh shit moment because I had to swerve dramatically. And why did I swerve? Well, there was a monstrous, about 2 foot wide snapping turtle trying to cross the road. So it was trying to cross the road like this. You're trying to go from one habitat to the next because that's what it needs to do. And so I almost killed this monster snapping turtle or potentially got into a bad accident because the habitat is fragmented by our roads. So again, this might not seem like a big deal, right? You could just walk across that, but this is a dangerous cross for multiple types of animals out there: birds, turtles, other amphibians, cats, dogs. Doesn't matter what it is. This is a dangerous crossing. And it's not just true here, it's true here as well. And it's true here as well, because while you might not have to worry about cars here or here, you have to worry about predators here, right? And so habitat fragmentation is kind of a bad thing. But the other thing that happens with habitat fragmentation is simply habitats like this are simply too small to support life. I can't have predators in here. It's just not enough space. So fragmenting habitats is dangerous, but it's also just simply not large enough. Now, one of the cool things we're seeing, now we see these heavily in Japan, we're seeing these in the Netherlands, and they're starting to pop up here in the United States, thankfully, is actually these cool wildlife bridges to span highways. So you can see we have this fragmented habitat by this highway in the Netherlands, and they built this bridge, they put grass, they put trees on it, so organisms can cross from one side to the other safely as best they can. Obviously, it's not perfect, right? Because an organism just could go whoop like that and get killed by a car, but it does a pretty good job of trying to solve that issue. So potential possible solution, but again, not a perfect solution because I mean, what are we going to do, right? Get rid of our roads, right? We can't do that. So now let's look at another case of what this means. And so I'm going to actually show you some cool, well, I don't know. I think it's a pretty cool thing from this paper published in 2010. Now this is oh shoot, oh my goodness, I forgot where this is. This is somewhere that I can't remember where it is, but you'll notice that this place is actually pretty fragmented. And so you'll see that there's this little pipe here, but it was actually fragmented. So you had basically this dam built right here that created a pond here and a pond here. So we had a habitat that was previously connected and now it was fragmented because, again, this little dam that was built. So what these people did is they got an excavator in here, they dug it out, and they put a pipe in here. And then they filled all the rest of the sand, and dirt and stuff like that to recreate the bridge and the dam that they needed. But it allowed connectivity between the habitats, very much like this wildlife bridge would do. And so you can sort of see the before and after pictures here, right? Creating a new habitat, allowing for connectivity. So what did this do? And actually, it's pretty cool. We can look at 2 metrics, so species richness or total number of species. As you can see, pre-restoration, there was about 8 species. In post-restoration, there was close to 16 species. So we had about a doubling of species or biodiversity in this area, just by getting rid of the patchiness of the habitat, right? Improving connectivity between habitats, getting rid of that fragmentation. And then we can see the harvest, right? The the grams of fish per meter squared per year, so how much harvest they were taking. And so you would see that prior to restoration, there was about 40-ish grams per meter squared per year. After that, we had about 5 times that at about 200 grams per meter squared per year. So pretty dramatic, right? Just by building a little pipe, taking one day, maybe a few $1,000s, restoring connectivity between this ecosystem, fixing a fragmented ecosystem. Fixing it restored richness and production, right? So we got both biodiversity and ecosystem services just by putting one $100 pipe between 2 habitats. Pretty cool. So the other part about habitat change is what we call LUC, or land use change. Now, land use change is pretty straightforward. It's changing a natural habitat into something anthropogenic. You might ask what that might be. It's building a city, building a town, growing food, or simply cutting a tree down to harvest it for timber. That's what land use change refers to. And it's not just forests, right? It's everything. It's grasslands, it's savannas, it's shrubs, it's everything. People like to live in biodiversity hotspots, right? And so we change the land in biodiversity hotspots quite a bit. And so just to sort of show you what that looks like, we can look at metric tons of hardwood, beef, and deforestation. So hardwood in yellow, beef in blue, and deforestation rates in green here. It's on this own little axis. But you can see deforestation has just gone up and up and up and up. In the Amazon, of course, I should preface that by saying this is the Amazon. And then you see hardwood harvesting has gone up and up and up, and it's starting to come down, at least in the early 2000s. And then you can see beef production is just going up and up and up and up. And so what's going on? We're cutting down forests, potentially just burning them. That's the sort of the easy way to cut down a forest, and then taking that burnt forest or that cut down forest and raising livestock, growing soybeans, something like that. And you could really see that actually in the Amazon basin. It's really dramatic, where you can see red dots here are active fire identified by satellites, and you can basically see the entire sort of middle section here is basically on fire, which is pretty dramatic for 2019. So lots and lots of land use change going on here. Why is there land use change going on for this? Now, that's a good question, Megan. Why would they burn it? Well, the question is, what's more valuable, the timber or the beef? And the other question you can ask is, do you have the infrastructure or the resources as a businessman if you're trying to grow cattle to sell that wood, or to even cut down that wood and move it in a meaningful way? And so the reality is, if you're just trying to go beef, which is a really, really successful business, it's just easier just to burn it and not have to worry about it. Now, in a perfect world, we wouldn't burn it. We would cut it down. We would use the timber for all different things, paper and so on and so forth, and then grow the cattle. But again, if you're just a farmer in the Amazon basin trying to get some cows to sell, to make some cash, support your family or whatever, it's just easier to set a fire, walk away, come back a few days later and have your cows graze on the forest that's starting to recover. So great question, Megan. But again, it's profits, right? It's easier to simply just not have to deal with it. It really is. So that's really what's the reality of a lot of things. If businesses can take the cheap way out, right? We all know they will, right? If I can avoid fixing a construction issue, I will, right? Because it saves me money, and that's the sort of thing that's going on here. So, and again, we can see all this land use change here in the Amazon, but land use change is actually something that we're seeing globally. And you can imagine, if I go from a nice, happy forest to this, I lose biodiversity along with it. And so land use change does, again, bring with it the loss of biodiversity. So we could look at changes in land use in on the global stage here, where we have forests in green and deforestation fronts, both ongoing and projected in the 2010s to the 2030s. And you can see basically all of our great forests, whether it's the Congo Basin, the Amazon Basin, the beautiful forests across the eastern islands of, the South Asian islands here, all undergoing or projected to undergo massive amounts of land use change. So now, to put this in perspective, the World Wildlife Foundation estimates about 7.5 million acres of forest are lost per year. People have actually sort of described this rapid change as what we would call death by 1,000 cuts, because as we change the land, we actually degrade the land. So cutting down a forest not only gets rid of the forest, but also makes the land less valuable, less able to essentially support biodiversity going forward as well. And so by cutting down forests, we get all this stuff from it. We hurt the forest in the short term. We also hurt the forest in the long term. And so people have described this idea as death by 1,000 cuts, because we're cutting down the forests, we're degrading the land, we're getting rid of the land. And again, we're just slowly eroding our forests. And yeah, so that's our land use change. Not so fun. So let's talk about the I in hippo, which is exotic species. Now this is, or introduced species. And so this is actually a topic I've worked on quite a bit. So I love this topic. This is my favorite part of hippo. And I've actually worked on it in the lens of this organism over here. You guys have definitely seen this if you've been in the Boston area. You guys all go to Bentley, so you've been in the Boston area. But this is actually an invasive reed called Phragmites australis. It's called the common reed. It's one of the most invasive plants on the planet. And so what does it mean to be invasive? Well, when something is invasive, it simply has moved from its previous range, and it's moved into a brand new range. So in the case of Phragmites australis here, it used to be only found in Europe, and it got brought over here by colonists. So the Mayflower and all the boats that followed, and it settled here in the United States as well, essentially spreading out throughout the entire United States. So that's what an invasive species. It's also called an exotic species as well. Now you might ask yourself, why is the introduction of a new species bad? Why is it bad? We're bringing new biodiversity. Shouldn't that be good? Well, the reality is these species actually exhibit some pretty stark characteristics. And I'm going to give you an example, not of Phragmites, because plants are really hard to sort of tease out what bad things they do. We're actually going to talk about this in the context of actually a pretty cool fish. And you guys have probably seen this fish before. It's the lionfish. It's Pteris volitans and Pteris miles. Two species of lionfish, really cool looking fish. You can buy them from aquariums. They're awesome. Now, the lionfish has a native range throughout the Indo-Pacific Islands, as well as all the way down the coast of Africa, as well as the Red Sea, and I forget what that place is called. I don't know, whatever that part's called. Like I can't remember all the names. So pretty big range of this fish. But I'm talking about this in the context of an invasive species. So clearly this species has to invade somewhere. And this fish actually invaded the Caribbean. So let's talk about how it got from this place to the Caribbean. Well, the reality is it actually was just brought here via the commercial pet trade. They're awesome looking fish. They look cool. They'd be great to have in a saltwater aquarium. So people brought them over here to sell them so people could have them in aquariums. But clearly they did not stay in people's aquariums. They got out. So when they got into aquariums, they got out in a number of mechanisms, including via hurricanes, in particular Hurricane Andrew, massive hurricane in the 90s, category 5, huge amounts of damage. Lots of these fish escaped during Hurricane Andrew. And subsequent hurricanes as well, I should say. We also know that many resorts were actually just releasing them. They would bring them over and release them into their water so people could see the fish because they're so cool. And we also see them getting out via ballast water, so like escaping like during like wastewater of ships and stuff like that. So they were directly being introduced by humans. And yeah, I don't know. I can never get this stupid thing to work. Anyways, I had a cool video, but again, it just never seems to work. So I'm sorry. I'll post the link to Blackboard so you can see it. But for some reason, I just can never get this stupid thing to work in a slideshow. It's going to show you how it expanded out, but it's not really that big a deal. So what made the lionfish so successful? Why is it? Why do we care? Why do we care if a species is brought from A to B? Well, the reality is, things that are invasive or have the capacity to become invasive have some pretty common characteristics about them. So lionfish, as with all invasive species, need numerous introductions. You can't just release 5 individuals in Florida and then they become invasive. They need multiple points of entry just to simply establish. They need enough population for them to establish. They typically, as an invasive species, reproduce very quickly. So these would be what we would consider typically our adapted species, right? Things like mice. They produce large numbers of eggs or large numbers of offspring. Again, a characteristic of our adapted species. And if you were to ask me, are all invasive species our adapted species? I would say, yeah, pretty much. Most invasive species are our adapted species. They have, in the case of the lionfish, they have very long pelagic larval life cycles, as you can sort of get at. They live very deep down for a very long time. Or not for a very long time, but they live deep down, so it's kind of hard to get rid of their larvae once they get there. They are habitat and diet generalists. They'll basically eat anything. And so you can see this lionfish here that was captured. You can see it's got all these different species of fish here, and it's got a little crawfish here, or shrimp, or whatever you want to call it. So they eat a lot, and they will basically live anywhere, which is kind of a cool thing. They have no native predators or prey. They're not like bears where they eat salmon, or they're not like mice where they get worried about eaten by like hawks and crows and all these things. Nothing was really designed to eat them. That they at least in Florida, of course, in the Florida region. Because they're not in their native range, they had no native diseases or no known parasites. Once they got out of their larval phase, they grew really, really rapidly. So they would go from basically a larva to an adult in basically a 3 to 4 month period. Very, very rapid growth. They also were venomous. Now, this one doesn't have any spines on it, but as I showed you in the first picture of them, they have spines on them, and those spines are venomous on both their dorsal side. So again, they would be here. Their anal fins are also, and their pelvic fins also have spines on them. So they are venomous. They also do some cool stuff. If you guys are interested in this, I recommend Googling lionfish and how they hunt, because lionfish actually, to capture prey, will oftentimes blow jets of water to disorient their prey and then gobble their prey up. So it's actually kind of a cool thing they do. And they also have some pretty wild physiological adaptations that are simply not found in the fish in the Florida region. And they basically can live in saltwater or freshwater. It doesn't really matter. They can live in either. So lots of crazy characteristics of this fish. But again, most of these things are pretty characteristic of most invasive species. Most are adapted species. So the question we can ask is, why do we care about the lionfish? Well, they do a couple things that we know of, but lots of things they do we actually don't quite fully understand yet. So we do know the lionfish, and it's been documented pretty heavily that they will actually directly consume juvenile fish, and they've been implicated with the decline of numerous fish species in the Caribbean because they're eating the fish. They also have been implicated to compete with other species of fish for prey items, so inducing some level of population control on other species of fish. They're also poisonous, so if you get stung by one, you could potentially die if you suffer from some severe allergies. But again, they're sort of disrupting these ecosystems, and that's clearly not a good thing. But the extent of why they're bad, we still don't fully grasp. But we do know they come in, they disrupt biodiversity, and that is bad. So we covered H&I. We talked about overexploitation already, but I'll just refresh your memory of what overexploitation is. It includes awful pictures like this of hunting endangered African wildlife like rhinos and things like that. So just being a jackass, for lack of a better way to call it, or over harvesting resources such as this vessel here that has thousands of shark fins. They catch the sharks, cut the fins off, throw the sharks back in the water because people believe shark fins have medicinal properties. It's not really accurate, but that's what people believe. And so it leads to an overexploitation of sharks as a resource. And so this, again, is directly tragedy of the commons, right? Overexploiting a resource for short-term gain at the expense of the long-term health. And the rhinos are a great example of this. We exploited the crap out of them for their horns in hunting and stuff like that. And now every species of rhino is about on the brink of extinction. Again, an overexploited resource. Now, climate change is also another way. Now, we'll talk a lot more about this in the climate change lecture, but I want to foreshadow it here. Climate change as a process is expected to threaten between 1/4 sorry, at least a quarter of all species on the planet by the year 2050. So climate change is projected to dramatically harm biodiversity worldwide. But again, we'll talk about this in a few classes. We're going to spend a bunch of time talking about climate change because, as we'll discuss, it is the defining issue of not only this class but also of just our generation. So, or generations, I should say. So, we'll come back to climate change in a few classes. So, that's Hippo. What can we do to reduce biodiversity loss? Well, the reality is restoration, as we talked about in the case of the Florida Everglades, it's good, but it's reactionary, right? I destroyed the Florida Everglades, but I'm trying to bring it back. And restoration is great, but again, it's reactionary. Sometimes if you destroy an ecosystem, you simply just can't bring it back to life. Now, that's conservation. So that's restoration. But what we really should be doing is conservation, protecting what we already have, because the Florida Everglades is a great example. Valuable, it's being restored, but that Florida Everglades is never going to be the same as it was before humans moved in. So how do we conserve things? Well, the reality is just protecting large pieces of land, protecting our biodiversity hotspots, preventing people from overexploiting resources, right? Those sorts of things are how we conserve biodiversity. And we better enforcing laws on the books. That's another big one. And not weakening our laws on the books, but only strengthening them and strengthening the penalties. Because the reality is most penalties for like a lot of destruction of wildlife are fines. And the people that are destroying wildlife, they don't care about $1 million fine. That's just the cost of doing business. So most people argue that jail time is the better way to go for biodiversity destruction and stuff like that. Just to put that out there. Now, other issues, other ways we could potentially do it is by having more zoos and aquariums. Now, there's also some pretty severe ethical issues about keeping animals in captivity. But the reality is, if you see a polar bear, you're more likely to protect that polar bear. And so by exposing people to animals, you're more likely to protect them. And I can tell you that that's 100% true for most people, because my deep love of nature stems from zoos and aquariums as a kid, watching documentaries on TV as a kid. That's where my deep love of these things stems from. So knowing that they exist, knowing why they're important, can convince people to protect them. Now, provided we can't conserve things and just be good humans to nature, actually doing things such as seed banks, and gene banks, as well as pollen banks. So storing species before they go extinct, their genetic material, their pollen, their seeds. So if they do go extinct, we can bring them back with their seeds, with their DNA, or with their pollen. And there's also some people, and we discussed this a tiny bit, but potentially bringing species back from the dead. And we discussed this in the context of the passenger pigeon, using our cool genetic engineering tools to bring back species that have gone extinct. If rhinos go extinct within the next 5 years, using cool genetic engineering to bring them back. But that's expensive. That's a hard thing to do. Now, we can actually sort of conceptualize what biodiversity conservation would need to look like. And we can actually do this with our friend E.O. Wilson, and he has a fantastic quote. E.O. Wilson says, to save biodiversity, we need to set aside about half the Earth's surface as a natural reserve. I'm not suggesting we have one hemisphere for all humans and the other half for the rest of life. I'm talking about allocating up to 1/2 of the surface of the land and the sea as a preserve for the remaining flora and fauna. And how can we do this? Well, the reality is it's just protecting some pretty key areas, right? The Amazon basin, the Congo basin, New Guinea are islands, right? These biodiversity hotspots, creating habitats in habitat corridors in industrialized parts of the world to prevent, habitat fragmentation from being such a huge issue, and potentially doing things like protecting large parts of the ocean, putting moratoriums on fishing in fishing industries that are destructive, such as shark fisheries. So there's lots of ways to protect biodiversity, but clearly there's a lot that needs to be done. And I hope I've convinced you that biodiversity is not only important for just the planet, but it's also important for sort of your average everyday life. So let's talk about some numbers, some hot off the press research. So this is all taken from this paper here, a really big paper that came out last year. And in this paper, they documented that about 58.4% of all land is actually under moderate to severe human pressure. And what does that mean? It just simply means that humans are encroaching on it. Land use change is occurring at an increased rate. So 58.4% of land, that is a massive amount of our planet. And between 2000 and 2013, about 1.9 million kilometers was actually heavily modified or just simply lost. And that's a massive amount of land. You're talking about, country-sized amounts of land. And we can see it's actually not uniform. Not every habitat on the planet is experiencing the same human-induced impacts. So we can see this human footprint here in red is highly modified, green is intact, and dark greens are like just pure wilderness. And you can see there are some pure wilderness, right? The Arctic here, large parts of Australia, the Sahara Desert, and a decent chunk of our Amazon basin and some parts of the Congo basin, a decent amount of the Asian islands, and a pretty hefty chunk here in Central Asia as well as here in Saudi Arabia and those on the peninsula here. And so there is some intact areas, but lots of our planet, including the tropics, is heavily damaged. You can see India is basically on fire, right? This area of China basically on fire, right? Europe on fire, eastern part of the United States basically on fire. So clearly we're changing the planet, but it's not a uniform change. And that's a pretty common theme we see. Change on the planet is not typically uniform. Certain places are hit much harder. Now, we sort of mentioned the United Nations in this lecture, and we mentioned that the United Nations did set some goals for, maybe I don't know if I mentioned or not. I think I did, but I could have missed it. The United Nations did set some goals for 2020 to try to preserve biodiversity, and we actually completely missed out on all trajectories of conservation, and it wasn't even close. So all the stuff we said that we were going to do in the early 2000s by 2020, we didn't even try to do, basically. And so I like this quote, and it says, global wildlife populations are in free fall, plunging by 2/3 because of human overconsumption, population growth, and intensive agriculture. And in total, about 2/3 of the world's wildlife was wiped out in the past 50 years. If you want to read a little bit more about that, take a peek at these 2 articles from The Guardian as well as Smithsonian, really talking about that. Of all these trajectories we tried to hit, we simply failed. Now, the reality is, how could we potentially fix this? Now, there's this really great article that was published in Nature. If any of this interests you, definitely read it. It's a really big article, really chock full of great information about this topic. But how can we fix our biodiversity problem? The reality is, we could do some pretty easy, they would be difficult to implement because people are stubborn, but relatively few number of things. So the big one is just actually food, sustainable agriculture. We'll talk about what agriculture looks like later in the semester, but don't farm and grow food the way we do now, and reduce the intensity of agriculture, allow places to recover, plant cover crops, things like that. That's sort of the big one, changing the way we grow food, because the way we grow food is really destructive. The other one is reducing food waste. Now, we'll talk about this a lot with climate change because it's a big part of climate change, but just throwing away less food, which means you're consuming less. Switching to less beef consumption, and that might be beef consumption in the sense of, I'm growing cows or growing pork, those sorts of things, or potentially switching to like those lab-grown meats that are starting to be piloted. That might be a potential good way of helping with this biodiversity crisis. But the reality is, all those things work, but as does protection and restoration, trying to bring nature back from the precipice that it sort of sits in right now. So let's go back to the question we started with, and this is the last slide. Why protect a polar bear? Why should we protect a single species? Well, there's a lot of answers to this question. I want you guys to think a little bit about it. Think about, if you were in an argument with someone and someone said, why do I care about one species? What would you say to that person? Now, what I would like you to take away for why to protect a species is that losing one species, it's not a huge deal, right? It's one species. There's millions of species, but the reality is the loss of one species in a species that is sort of prominent in its ecosystem as a polar bear is really a symptom of the larger decline in biodiversity. So the loss of one species, I would argue, and most people argue, is not a huge deal. But again, it is a symptom of a larger problem. If you lose a species as important as the polar bear, you're inviting the loss of other species. And then as we lose species, we lose our ecosystem and we lose all the services that it provides. So why protect a polar bear? That's my thoughts on it. But I want you guys to think a little bit about it. I sort of hope you sort of understand the sort of state things are in. I don't try to do these things to like scare you. You might get that. I don't know. Sometimes people get that idea of like I'm trying to scare them, or I'm just trying to give you the facts. Like I'm just trying to show you where we're at and what sort of dire crisis we're in. What you do with that information, how you feel about that information is really up to you. But again, I'd like you to sort of reflect and think a little bit about that. And one way to really reflect and think about this is to actually, if you want to, this is a completely optional discussion board. You don't have to do it. But if you want to do it to get you thinking a little bit more about this question of why to protect a polar bear, hop on over to the IUCN site. Select a plant and animal species, select something that you think is interesting, right? Potentially something that's endangered or threatened, or maybe something that's not threatened. And based on the information, and do a little bit of research online, if you lost that species, so say you like tigers, what would happen if we lost tigers? What would that mean to the forest of Asia? What if we lost lions? What would that mean to the savannas of Africa? And that really sort of puts this idea of why protect a polar bear into perspective. So I will create a discussion board on Blackboard for you guys. If you want to do this, it's completely optional. It's not graded. Great. If you don't want to do it, I understand. But again, I wanted to just sort of get you guys thinking about that question. And the best way to get you thinking about that question is think about what happens if you lose your favorite species, right? If I lost, I don't know, for instance, I really like red-winged blackbirds. What would happen here in Massachusetts if we lost those red-winged blackbirds that I really like? Anyways, so that's part one of today's class. No, you don't need to reply to anyone's post. I just want to see what you guys are thinking. This is not a graded discussion board. It's completely optional. If you don't do it, I won't think anything poorly of you or anything like that. So don't worry if you don't have time to do it. But again, it's a great exercise to get you thinking about how one species matters to its ecosystem. So it's a lot of stuff. All right, so that's the first part of class. Now, would you guys like a break? To sort of chill out for 10-15 minutes. Generally speaking, the exam reviews only takes about like 20 minutes or so. It's maybe 30 minutes. But would you guys like a break? You just want to keep pushing through. Well, I got 3 people, and that's about 1/7 of the class. So I'm going to say that's reflective of everyone. All right, so, oops, I did not mean to do that. So if you perused over to Blackboard, you would see there's a study guide for you. This study guide is just a Word document. It's got topics in it. That's there for you. And then you'll see there's review slides. That's what we're going to go through right now. So these review slides are basically the slides from our lectures thus far that I've pulled out that you're basically going to be tested on. Now you might ask yourself, what lectures do I need to sort of think about? Just to sort of go back to our syllabus, we're going to basically cover most of the lectures. The one lecture we're not going to cover at all, I'm going to save for the second half of the course, for the second exam, is actually the water and air lecture. So the water and air lecture, don't need to worry about it at all. We're just going to be covering Intro to Environmental Science, Welcome to the Anthropocene, Ecosystem Services, and a little bit of ethics and economics, populations, urbanization, as well as today's class of biodiversity. So no need to worry about water and air. Again, we'll come back to water and air for the second exam because it fits much better in the second half of the course. But I don't know, I divide the course into like basic science and then like applied science, and learning about water and air is more of a basic science sort of thing. So that's why we cover it here. So, but again, those things are there for you. Now, next Wednesday, right? Next Wednesday, right? When your exam is, what you'll do is you'll log onto Blackboard. You don't need to do anything special. You just come over here, you click this exams and quizzes folder. The exam will be hanging out right here for you. You click on it. It'll tell you about the exam. Like you have this much time, blah, 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 all the stuff. It'll give you like some basic instructions, but let's talk about what to expect. what should we expect? Now, if you have any questions along the way, let me know. But as I think I sort of mentioned in the first class, I will only test you on things that I've covered in lecture, and things that and very little on the things that I've assigned. So what we're going to go through today, we've covered in depth at some point during the semester. So you don't need to worry about finding extra knowledge. If you have your slide deck open, that'll have all the knowledge you need to answer the questions. So let's talk about this exam. So the exam is timed. Now, you might ask me, why are you timing us? The reality is, if I don't time you, it makes the exam significantly easier. And it really does. So generally speaking, I give students about 2.5 hours or 2.5 hours, so 2 hours and 30 minutes to do this exam. Now, if we look at sort of the slide here, we have 20 multiple choice questions, 7 short answer questions, and 2 essay questions, giving you a grand total of 100 points, or 25% of your grade. So it is worth a bit of your grade, but it is fully open notes, fully open, technically open book, but you don't really have a book, fully open internet. So you have all the resources at your hand to use. Now, this exam will go live on the day of the exam. So next Wednesday, it'll go live at 12:01 a.m. and it will disappear from Blackboard at 12 p.m. that night. So there's a 24-hour period for you guys to do the exam. And I'll let you guys, I'll remind you guys of this information before I post the exam to Blackboard, don't worry. But there is 24 hours for you to do it. So you can start it at 12:01 a.m. or you can start it at 10 p.m. that night. It doesn't really matter. As long as you start it within that 24-hour period, you'll get the full 2.5 hours to do it. So I do that just to make things easier, because sometimes people they need to go to the store or something and it's not convenient or whatever. In terms of that time period, if you have any special accommodations, I think there's at least one person, please let me know so I can set that up on Blackboard for you so you get all the extra time that you need. That being said, if you're working on your exam and you're just having a tough time and you feel like you're running out of time and you're like, I could really use another 10 minutes on this, or I didn't get to upload my essay because the exam finished on me, just send me an email. Like for instance, if you're working on your essay and you didn't get to submit or something, or you didn't get to finish typing a few sentences, just send it to me. I've been more than happy to just count it. I don't want I put the time limit because, again, if I don't put a time limit, it's way too easy. But I don't want to put the time limit as being it too hard. But 2.5 hours seems to be about the sweet spot. So, but again, 20 multiple choice, 7 short answer, 2 essay questions. I will give you the essay questions beforehand. So just to let you know, you'll have the essay questions before the exam even starts. So that's a pretty cool thing. Now, what you do with those questions is up to you. So I know some people, will write the essay beforehand, and you can do that. I will never know the difference. Or you can write notes that you want to take for the essay and then type the essay out during the time. Or you can just say, screw it, and I'm just not going to look at the essay question that the professor sent me. You can do whatever you want with that information. Whatever you want, you do with it. But you'll get the questions. I'll send them later today for you guys. So you'll have the essay questions. Now, the other question people ask me really, really commonly is, how much do I need to write? And the reality is, I want you to write as little as possible. and I say that for 2 reasons. The first is, I don't want to read a 10-page paper, and you don't want to write a 10-page paper. That much I know. I know no one in their right mind ever wants to write a 10-page paper, and I certainly don't want to read 24 10-page papers. That's awful. Second, I want you just to write enough to answer the question. So if you can do one of my short answer questions and it takes you 2 sentences and you answer the question, great. If it takes you 10 sentences, okay. If it takes you a paragraph, 2 paragraphs, a page, okay. But just write what you need to answer the questions. I'm never going to take points off if you write too much. I'm never going to take points if you write too little. Simply just answer the question. As long as the answer to the question is there, you'll be fine. That's what I look for. I don't look for, like, I know you guys probably have professors like, oh, a minimum of 5 pages. I think that's dumb. I really think it's dumb. As long as you answer the question, that's all I really care. Now, the essay questions, they should be longer than the short answer questions because they require a little bit more thought to answer. So just as an FYI, the essay questions are going to require a little bit more girth in terms of length to really get a good grade on them. Just to let you know. But again, I have people that answer short answer questions in one sentence and get full credit. So just as an FYI, don't be like, oh, I only wrote 2 sentences for this. I don't know. As long as you provided the information for the question, you'll be okay. Now, the final thing I'll say about sort of a logistical thing, I will be available the whole day. So if you have any questions, just answer me. I'll try to answer back as fast as I can. I'll be slower to answer if it's at 10 o'clock at night of that day, but I'll try to answer as best as I can for you guys. And if you need like a Zoom call because I can't explain something over email, just let me know. I'm here for you to help you guys. Try to make this as stress-free as possible, but I know that that's never a thing with exams because exams are inherently stressful. And then the final thing I'll say is when you are writing, I do not want to see a single quote in your answer. This is an exam. This should be in your own words. So if I tell you that biodiversity, we're currently in the middle of the 6th great mass extinction, you can't take my words in quotes and put them as your answer. You need to take what I said, put it in your own words, and then answer it. So just to let you know, if you put a quote in an answer, you'll just get a 0 for that question. I won't even try to read the answer and see if you got it right. I'm just going to give you 0. Just to let you know, this is an exam. I need to see your thinking on the matter. I don't need to see what some guy on Wikipedia wrote or what some scientist wrote on his blog. I need to see what you have. So, all right. So does anybody have any questions about the sort of the logistics of the exam? I think I hit all the main points. And I think I got most of the questions most people usually ask. If you don't think of a question now, or you forget something, let me know. I'll post like the stuff to Blackboard the day before the exam, so you'll have the information just in case you forget it. Or if you have any questions in the meantime, again, feel free to reach out. So, all right. So, what are the topics? So we got 41 slides to go through. So let's go through them. Let's talk about some of the key points. And I brought these slides together for a very specific reason. When I wrote the questions, I pulled the information from these slides. So this is a pretty good study guide. I make good study guides because I hated my teachers when I was in college. They made the worst study guides. They would say, oh, just study chapter 5 through 10, or study these concepts, or anything like, but it would be so broad, you would never know what to study. So you would have to study chapters and chapters and chapters of stuff, and then only a small proportion would be in the exam. And I hated that. I hated that so freaking much. So my study guides, not to pat myself on the back, but they're the bee's knees of study guides. So everything you need to know is in the study guide. So don't fret. I got you back. So the first thing we really discuss is the Anthropocene. Now, remember, the Anthropocene is the time by which humans are on this planet, right? The part where we started making a meaningful impact. You're welcome, Samantha. Like I said, I'm not that much older than you guys, so I remember what college is like. So I remember being angry at my cell biology professor and my genetics professor for their crappy study guides. So, plus you guys aren't scientists, so you guys, you shouldn't have to worry about terrible science teachers. So anyways, so the Anthropocene, humans affecting the planet. Now, how do we affect the planet? Well, it's lots of ways, right? We alter the atmosphere, we alter the geology, the water, the biosphere, and every other system you could think of. That's what the Anthropocene really gets at. And that sort of dictates the rise of humans, right? Now, it's not just like modern times where we're destroying the planet or altering the planet. It's basically since day one. And that's really a function of sort of us as a species. We're very, very intelligent. We use tools very, very well. But the Anthropocene is a pretty long time period. Now, we see sort of records of this throughout history. We see massive extinctions events, including loss of 72% of all mammals on the continent of North America. And we saw this really come to fruition with the advent of 2 key industrial applications. The first is agriculture, and that was about 11,000 years ago or so. As we saw in today's class, land use change for agriculture is kind of a big deal. That was the first one, right? Agriculture. Agricultural revolution way back in the day, that led to the domestication. Now, domestication is, I spent a bunch of time talking about this because I really like it, because I like lots of things that most people don't like, but domestication is really cool. taking a wild plant, a wild animal, selecting for traits that make it better, more nutritious, easier to grow for humans, which leads to scenes like this, where we see massive yields of corn per acre. Now, remember the wild relative of corn, this little happy guy here called teosinte, about 5-ish bushels per acre. Domestication of corn led to essentially a 4 times increase, or 4+ in times increase, to well over 20 bushels per acre. And then when we paired that with fertilizer, industrial fertilizer, it led to an explosion of corn yields over time. So domestication, super duper important. Without domestication of plants and animals, we simply could not sustain the massive population that we have right now. It's just impossible. You can't feed a population of 7.5 billion without this. There's just simply not enough arable land on the planet to grow 20 bushels per acre and then feed the entire planet. It's just simply not possible. Now, we discussed the tragedy of the commons, but we discussed 3 distinct ways to think about the planet. Now, we have the anthropocentric worldview, i.e. only human lives matter. The biocentric worldview, where every organism matters, and then the ecosystem worldview, where the entire connected system matters. I hope the ecocentric worldview was really sort of tied in together nicely today with the biocentric worldview, about how they're really interconnected and how they really sort of prop one another up. I hope that was clear today about that sort of role that they are together. But those are the 3 worldviews. There's a question on that, just to let you know. Then we discussed the tragedy of the commons. Now, remember, the tragedy of the commons is exploiting a resource in the short term at its expense in the long term. The passenger pigeons was our example here. We harvested the crap out of the passenger pigeons, right? I showed you that picture with the mountains of passenger pigeons that somebody killed. We overexploited that resource, and that led to an extinction event for our passenger pigeons. And so we tragedy of the commons, it's probably, I guess it's a verb now. The passenger pigeon, again, exploited it, overused it as a resource. And in terms of biology, that means going extinct. That's what that ultimately means. But we can also think about tragedy of the commons in the lens of, say, fossil fuels, right? We've used fossil fuels for well over 100 years now. There's going to come a point in time, not too far from now, where things like oil and natural gas simply are not accessible in the way they are now. And so tragedy of the commons doesn't just apply to animals. It can also apply to natural resources such as fossil fuels. So those are the sort of the key things to remember about tragedy of the commons and the Anthropocene and the rise of humans. The next thing we sort of dove into was ecosystems. Now, what is an ecosystem? It's sort of this dynamic system that varies depending on where you are on the planet. But it's an interplay between what's alive, i.e. the biotic components, and what's not living, the abiotic components. And they both influence one another. So if you have lots of sunlight, that influences all your plants, which are primary producers, which in turn influences all this stuff, which then in turn influences all this stuff. So everything in an ecosystem is connected. They change not only in different spaces. So Massachusetts has a different ecosystem than Australia does, or Arizona or Florida, but they also change over time, right? Your backyard looks different today than it's going to look in December or February, right? So ecosystems change over time, but again, they are a connection between the two of them, between the living and the non-living. And again, they both influence one another in both directions. Now, biodiversity, as we discussed today pretty heavily, they underpin the way ecosystem functions. So loss of biodiversity leads to a loss of ecosystems, right? You lose biodiversity, you lose the health of ecosystems. And that's a really important thing to take away, not only from today's lecture, but also from sort of the example I gave you here. More biodiverse ecosystems simply function better. Now, we talked about this in the context of ecosystem services, right? Putting a dollar value on nature, it's hard, right? But it's doable. And so we can do it by assessing ecosystem services, which is just simply a term that describes what things nature provides for us, what things that have a tangible or sometimes intangible value to the human population. So those are divided into 4 distinct categories. So let's talk about those. The first is our provisioning services, things we take: food, water, timber, plant fibers, natural gas and oil, things we can take and sell Medicine is also one of those things. So for those of you that have ever had a headache and you took aspirin or acetaminophen, Tylenol, or ibuprofen, Advil, you took those medicines that were derived from nature. So kind of a misunderstood aspect of a provisioning service. We can derive things from nature and then move them into a lab to make them. And it's still considered a provisioning service. Then we have the regulating services, these that help maintain ecosystem integrity. Remember, we defined ecosystem integrity as the overall health of an ecosystem. If there's high integrity, we have high ecosystem health. Low integrity, low ecosystem health. And so we think about it in the context of today's class. Low integrity means something that has the land use changes dramatically changed or degraded the ecosystem. We have very, very high integrity, means we have a very pristine ecosystem with very little land use change. So making that connection, because they're connected. These include some things that we don't really quite think about, but are very, very valuable. Remember, I told you pollination is worth billions of dollars every year to the global and the United States economy. But lots of things, including protecting our coasts, protecting purifying water, purifying air. As we talked about, water and air purification are kind of a big deal, right? We have lots of polluted waterways, lots of polluted airways. And so these ecosystem services, while we don't think about them, are very valuable. Then we have our cultural services, our direct connection with nature, art, music, recreation, spiritual sustenance, science education, all that good stuff that we can use nature for without taking anything from it. It's just appreciating nature for all the awesome things that nature actually does. And that's our cultural services. And then we have our final one where we have our supporting services. These are just the underpinnings of the ecosystem: photosynthesis, cycling of nutrients, things like that. So pretty abstract one, but again, clearly a very important thing. Now, just to sort of connect this back to today's lecture, and sort of actually connecting it back to this slide as well. Ecosystems that are very biodiverse have a lot more photosynthesis, process nutrients better, form more soil, cycle water better, and form more habitat. So again, biodiversity underpins not just this one, not just this one, not just this one, but also this one. So biodiversity is really the bee's knees. Now, there's a question, I'll just tell you this right now. There's a question, a short answer question about the Florida Everglades and about this slide, about the return on investment, why it's so valuable to the Florida Everglades. Why is the Florida Everglades so valuable, and why is restoring it a good idea? So just to let you know, there is a very valuable thing. Now, one thing I actually failed to mention, and that's actually in my notes here, it was estimated to actually create about 442,000 jobs for both the state of Florida and the surrounding areas. So a really valuable, economic piece as well. Not just these things, but also like, hey, I have a job now. It's kind of always always a good thing. Especially that's like the focus of every presidential election is, I'm going to create jobs, right? And clearly ecosystem restoration creates a sizable amount of jobs. But again, the Florida Everglades, really, really successful and really, really important restoration. But again, we restored ecosystem services, our provisioning, our regulating, as well as our cultural ones, and our supporting services, bringing this ecosystem back from its tarnished state into a less tarnished state, giving us about a 4.04 return on investment. So again, every dollar you invest into the Everglades to restore the ecosystem, bringing back biodiversity, which in turn brings back these services, nets you a return of $4.04, or for an $11 billion investment, you get back $46 billion. So not a bad chunk of change for the state of Florida and the surrounding region, as well as all the people who are employed to do this actual sort of thing. So the next sort of big thing we discuss was populations. Now, we defined a population of a set of species living in the same area. I gave you a species as a group of individuals capable of breeding and producing viable offspring. That's what a population is, just to refresh your memory. And we can talk about how to structure a population. And you guys did this to an extent in your lab, by sex, by age, or size, if you're talking about plants. But when we think about population structure, we're thinking about when organisms are going to die, how old do they make it to, and we can really think about this by thinking about how fast the population grows. And we did talk about two distinct types of growth: the J curve, which is our exponential growth. This is something that our R-selected species do, right? Our mice are the characteristic R-selected species. Though we did talk about the lionfish today, and the lionfish also follows the J curve once it came here, just to let you guys know that. But the J curve, again, by R-selected species, really rapid rise, right? Exponential growth, really rapid. But exponential growth can't last forever, right? It's limited by resources, food, water, space, and an increase of density dependent factors that we'll talk about in just a moment. But typically speaking, we have more what we call logistic growth, or an S curve, where population grows decently fast, but eventually hits a ill-defined K, or carrying capacity. It's hard to determine what K is, just as a note. That's why I call it ill-defined. But remember, K really does stand for the maximum amount of individuals that a place can sustainably keep indefinitely. So if that number is 500 elephants, carrying capacity of elephants would be 500, right? So it's kind of hard to determine, but there is an upper limit on how many individuals you can have in a set area. Again, it's all based upon resources, right? If there's a lot of resources, you can have more individuals. If there's few resources, you can have less individuals, right? So it's like, think about if like you have a pizza party, right? if I have one pizza, I can only have, say, 2 friends over. But if I have 10 pizzas, I can probably have 10 friends over, because most of my friends like to eat pizza a lot. So, but you get the idea. Little bit of pizza, small population. A lot of pizza, a lot more people. And that's what we're seeing with carrying capacity. And it does vary between organisms. And just as a reminder, the S curve is very much what we see for oh my goodness, K adapted species or K selected species, such as humans, as well as elephants. Now, we talked a little bit about 2 factors that limit population growth. Now, the first one we talked about was density dependent factors, which is reflective of how dense your population is. The more dense your population gets, the more likely these are to help limit your population's growth. And as your population gets more and more abundant, more and more dense, you get more predation, you get more disease, and you get more competition for resources, competition for food, competition for water, competition for space, and competition for breeding partners all increase as your population simply get larger. Now we have our density independent factors, which don't really give a crap how big your population are. If you get hit by a flood, they're going to knock your population down. That's simply what they are. So it doesn't matter how dense you are, floods, storms, avalanches, natural disasters act as a way to limit population growth, population size. And so I've sort of defined these already, but we have 2 distinct types of species. The K-selected species, that's us, elephants, things like that. Slow growth, and all those sort of characteristics about them that you can find on the slides, but aren't super duper important for this exam. And then we have our R-selected species, fast growth, really characteristic of things like mice, or potentially the lionfish, as we discussed today. So 2 distinct types of species that I would recommend that you just become familiar with in terms of what differentiates them. And again, what really differentiates them is just how fast they grow. R-selected is fast, K-selected is slow. It's really the sort of the easiest way to remember that. The elephant versus the mouse, right? That's the way I've remembered that for 10 years, and I think it's a pretty good way of remembering that. And then we sort of talked about this issue of overshooting and crashing. Now, we talked about it with a pretty cool example, at least in my opinion, of the reindeer on St. Matthew's Island. But our selected species can pretty easily, with their rapid growth, overshoot their carrying capacity, run out of resources, crash in population, and then rebound relatively rapidly. So we see this relatively commonly with our selected species. Overshooting, crashing, pretty dang common for our selected species, not very common for K-selected species. Then we discussed, and you guys also created your own survivorship curves for your cemetery data, where we have 3 distinct types of survivorship curves. And remember, what matters for these curves is how to read them, right? I don't care that you know that type 1 is for R selected or K selected or any selected species, right? I just want to know that you can read them. That's what's most important for these curves. So type 1, remember, it's very low mortality early on in life, very high mortality late in life. So if you have type 1, you're likely to live to old age, and that's pretty easy to understand when you think about humans, right? The average life expectancy of humans is in the 70s, right? Well, sometimes it's higher, but on average, it's in the 70s. Type 2, well, if you're a lizard, it doesn't really matter when you're equally as likely to die old or young. It doesn't really matter. That's what type 2 looks like. And then you have type 3, which is would be pretty characteristic of things like mice. Those are selected species. High mortality early on. Very few individuals living late into life. You see very few old mice in nature. Most of the mice you see in nature are young. Oh shoot, I forgot to get rid of this slide. You can ignore these things just as an FYI. I realize those are there and they're not supposed to be there. Anyways, we'll get to there in a second. So we talked about the human population. We add about 85 million per year. We're at about 7.5 billion, with a projection of close to 10 billion by 2050, with most growth occurring in rapid, low income countries in Africa, Southeast Asia. Changes in population size globally, it's a balance between birth and deaths. But at the local level, it's a balance between birth, deaths, as well as immigration and migration as well. You can ignore these couple slides. I was originally going to have these, but I was going to put these in to move. I was originally going to have this be part of the exam, but I realized that I didn't talk about these things. So you can ignore slides 29 through 33, or actually through 34, because we haven't talked about those yet. We will, but we haven't talked about them yet. So ignore these slides. They're from another part of class we'll discuss later. I just completely forgot to remove them because I'm stupid. But again, don't worry about these guys. 29 to 34, you don't need to worry about. And so then we have the slides from today. But what biodiversity is, it exists at the 3 levels: ecosystem, species, and genetic diversity. Biodiversity does underpin our ecosystem services, all of them. It doesn't matter even if it's cultural services. A high biodiversity ecosystem is better for people to go hiking in, because if you have high biodiversity, it means you have very little land use change, which means you have a healthy ecosystem, which means people want to walk in your ecosystem, right? Or go fishing or whatever. So biodiversity, we can't live without it. Huge amounts of economic value. Then we discuss where biodiversity is found. It's in hotspots, right? And hotspots have lots of biodiversity because of high amounts of endemism, i.e. species such as the Florida manatee, which are only found in one spot on the planet. And in the case of the Florida manatee, it's found only down with our friends in Florida. Then we sort of looked at where biodiversity hotspots were. You guys had some fantastic ideas about where biodiversity can be found. Lots of warm places, lots of islands. We find biodiversity mostly along the equator. So biodiversity is found everywhere, but has some hotspots along the equator. Then we talked about the Endangered Species Act, how it's really great, how many species have saved from extinction from it, but has been weakened through some extent, but is making a little bit of a comeback nowadays under the current administration. I do hope that the current administration does beef back up the Endangered Species Act, because again, it is so good. 99% success rate is really good. And as we discussed, losing species is not worth saving a logging company a few $1 million, or a fossil fuel company a few $1 million. It's just not even close. So, and then we talked about how to reduce biodiversity hotspots. We talked about zoos and aquariums and enforcing laws in the book, protecting species. But we also talked about E.O. Wilson's Half Earth, protecting about half the planet. Again, not like dividing the planet in half sort of thing, as this quote tells you, but really protecting what we have, protecting our biodiversity, which in turn protects our ecosystems, which in turn protects the services, which in turn protects all the dollar bills we derive from our healthy ecosystems. Because remember, a degraded ecosystem is not super value, right? The shrimp farm, not very valuable. It's a net loss. But the healthy mangrove down the coastline, super valuable, even if we're not directly taking money from the ecosystem by selling timber or selling fish or something like that. So those are the key points for next week's exam. Again, what you'll see in this will simply be what's in these slides, what we covered today. Again, ignore these 5 slides or so. Again, I just, in my brain, I thought I was gonna cover these. These are gonna be on the exam, but I just made a mistake. They're not on the exam at all, so you don't need to worry about them at all. So just as an FYI. But those are the sort of the key takeaways. Now, this little review session, you'll have, I'll post the recording to Blackboard later this afternoon. I think I'm a little bit behind on posting the recordings as well. So I will post those today. I do promise that. It's just a pain in the butt to upload things to Blackboard. The videos, they take forever. Like sometimes it takes like 30 minutes to upload a video. And it's not because of the internet, it's because of Blackboard's stupidity. So you will have this recording for yourself. So, and you'll have the slides. So don't worry too much. You'll have all this material for you. In terms of the exam, you'll have all the materials at your side. So I anticipate the exam to be, have some difficulty to it, but also I don't want you to be super stressed about it. Feel free to reach out to me if you need any help, or you want to talk on Zoom, whatever, just let me know. But again, what we covered today, the points I made today, the slides we covered today, that's what you really need to know. So don't worry about learning everything in the world. Just learn what I told you to learn today and you'll be a-okay. So I'm going to stop recording